Good evening. Welcome to ISC Class 12 Maths. Today's topic is derivatives of logarithmic functions. Here are some important formulas. Just have a look. There are 20 formulas. The first formula is f dash x is equal to limit h tending to 0 fx plus h minus fx upon h, where f dash x is the derivative of fx. Finding out the derivatives, that is differential coefficient of a function using this formula, is called differentiation using definition or from first principle. Means if you are using this formula to find out the derivative of a function, so we say that okay, we are finding out the derivative using definition or from first principle. Second formula, c is a constant, so d dx of c is equal to 0. That means ddx means differential coefficient with respect to x. So differential coefficient with respect to x of c means any constant is equal to 0, where c is a constant. Third, d dx of x raised to the power n is equal to n x raised to the power n minus 1. Once again listen, d dx means differential coefficient with respect to x of x raised to the power n. Fourth, d dx of x is 1. Fifth, d dx of 1 upon x is minus 1 upon x square. Sixth, d dx of c into fx, where c is a constant. So that c will come out c and d dx of fx. We'll keep aside c, it is a constant, and we will differentiate the function fx. 7, d dx of u plus v is equal to d dx of u plus d dx of v. 8, d dx of u minus v is equal to d dx of u minus d dx of v. 9, d dx of uv product. First function u d dx of v plus v d dx of u. 10, d dx of u upon v, quotient. So denominator into d dx of numerator minus numerator into d dx of denominator upon denominator square. 11, d dx of sin x is cos x, d dx of cos x is minus sin x, 12. 13, d dx of tan x is sec square x. 14, d dx of cot x is minus cosec square x. 15, d dx of sec x is equal to sec x tan x. 16, d dx of cosec x is equal to minus cosec x cot x. 17, d dx of e raised to the power x, exponential function, is equal to e raised to the power x. 18, d dx of a raised to the power x is equal to a raised to the power x log a base e. 19, see this is important for this chapter, this exercise. 19, logarithmic function, d dx of log x to the base e is equal to 1 upon x. And 20, d dx of log x to the base a is equal to 1 upon x log e base a. Alright. Now from those 20 formulas, once again you see the last two formulas. One is d dx of log x, base is e. So d dx of log x to the base a is 1 upon x, and d dx of log x to the base a, here base is e and here base is a. So when base is a, then 1 upon x log e base a, this is a numerator. If you take this in the denominator, then this will become log e. So that also you can write down is equal to 1 upon x log a to the base e. This is also alright. So if you are writing in the numerator, it is log e base a. If you are taking in the denominator, then it becomes log e base e. Alright. Now let's see some question. Note down please. Write down. Note down the question. The first question is y is equal to, the function is given y is equal to log cos x. The first question is y is equal to log cos x. we have to find out dy upon dx. Alright? So on differentiating both sides with respect to x, we get, you may write down this. You may write down on differentiating both sides with respect to x, we get dy upon dx. So dy upon dx is equal to ddx of log cos x. Alright? See, nothing I have done, only d dx, the operator d dx, this side also and this side also I have written down. Correct? Alright? Okay, d dx, only d dx of y is already given. Y is already given. I am writing d dx on both the sides. That means differential coefficient with respect to x of y. Though we read it dy upon dx, but actually it is not dy upon dx. It is not one quantity divided by the other quantity. It is d dx of y. That means differential coefficient with respect to x of y is equal to differential coefficient with respect to x of log cos x. Alright. Now d dx of log, when no base is written, that means the base is e. If base is other than e, then it will be mentioned, it will be written down there. So here there is no base, that means the base is e. Okay, so d dx of log x, as you know, d dx of log x is 1, base is e, so 1 upon x. d dx of log x is equal to 1 upon x, but in place of x we have cos x. Understand? Try to understand. d dx of log x, this we are taking as x, full cos x. Cos x we are treating as x, suppose x. So d dx of log x, whole x, that will be 1 upon x. But this is not x. So what we do, we once again differentiate this and we write down d dx of cos x. Because it is not x, that's why we are differentiating once again. Right, now 1 upon cos x and d dx of cos x is minus sin x. See the formula given. From that formula you see minus how much? Sin x. d dx of cos x is minus sin x. Alright, now this gives you minus sin x upon cos x. That gives you, that is equal to minus sin x upon cos x, and this gives you sin x upon cos x is how much? Tan x. So you are getting minus tan x, and this is your answer. Minus tan x is your answer. So dy upon dx is minus tan x. Got it? Understood? Now see next question. Next question is question number 2. Next question, please write down y is equal to log x upon, y is equal to log x, 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 like this, huh? Y is equal to log x. Y is equal to log x. Again, on differentiating both sides with respect to x, we get, alright, so dy upon dx is equal to ddx of log and then log x. Alright, now again we treat this as x, this total, this we are taking as this, suppose x, suppose this is x. So d dx of log x, though it is not x, it is log of x, but we are supposing this is x, and we want to apply the formula of log x. So d dx of log x is equal to 1 upon x. Fine, base is e. So d dx of log x to the base e is 1 upon x. Okay, alright. You know the formula I have given you. So 1 upon x, but Rx is log x, so we write down log x. And since it is not x, so we once again differentiate it. We write down into, I am writing, though it's not required, you can write down directly, but I am writing. So dx of log x. This log x, once again we are differentiating. You know why? Because this is not x, it is log x, and we are treating this as x. D dx of log x is equal to 1 upon x, right? And once again we differentiate this log x because it is not x. Okay, now this gives you, this is equal to, please note down, did you note down? Now this gives you is equal to 1 upon log x, and d dx of log x is equal to how much? 1 upon x, right? Because base is e. No base means base is e. See here, d dx of log x to the base e is 1 upon x, formula. The last formula, I think, 19, formula number 19. Okay, and this gives you, so finally you are getting 1 upon x log x. 1 upon x log x is your answer. Alright. Then you are getting is equal to 1 upon x log x. This is the answer. 1 upon x log x. Got it? Now next question. Next question is y is equal to log x upon 1 plus log x. Did you note down? Understood? Okay. Now question number 3. Third question. Third question. Y is equal to log x upon 1 plus log x. Y is equal to log x upon 1 plus log x. Okay, we are going to differentiate this. Y is equal to log x upon 1 plus log x. Okay, now tell me what to do. One formula I have given you, if you see there, u upon v, quotient formula. U upon v. There is one function u, there is another function v. Alright, and we apply the formula of u and v, u upon v. Okay. uv. What's the formula? Denominator into ddx of numerator minus numerator into ddx of denominator upon denominator square. That formula we are going to use because this is of that form u upon v, where this is u and this total is v. Alright, u upon v form. Now let's differentiate u upon v form. U upon v. So denominator. Again you write down on differentiating both sides with respect to x. On differentiating both sides with respect to x, we get on differentiating both sides with respect to x, we get dy upon dx. Dy upon dx. And this is equal to d dx of full log x upon 1 plus log x. Alright. Nothing I have done, only I have written ddx on both the sides. Okay. Now we apply the formula, quotient formula. Quotient formula we apply, and the formula is denominator into ddx of numerator into ddx of numerator log x minus numerator into ddx of denominator into ddx denominator into ddx of numerator minus numerator into ddx of denominator 1 plus log x upon denominator square. Denominator into ddx of numerator minus numerator into ddx of denominator upon denominator square, that is the formula. And then we get, this is equal to, down we get 1 plus log x whole square, and here we get 1 plus log x. Now ddx of log x is 1 upon x minus log x, and ddx of 1 is 0. Right? ddx, so inside the bracket ddx of 1 is 0 and ddx of log x is 1 upon x. So 0 you need not write down. So 0 plus 1 upon x is 1 upon x itself. Right? So into 1 upon x. Got it? Fine. Now I delete this. Now let us simplify. 1 upon x we can take common. 1 upon x here also we can take common. In the denominator we have 1 plus log x whole square, 1 upon x common, and what are we getting? We are getting inside the bracket 1 plus log x and minus log x. Is this 1 upon x common? Here you are getting 1 plus log x minus log x, and then you get and this is equal to 1 plus log x whole square, and this minus log x and plus log x cancels each other. So you are getting 1 into 1 upon x means 1 upon x. So that gives you 1 upon x. This x will go down. This x will go down, and then you get, in the next step you get, is equal to 1 upon x 1 plus log x whole square. This is the answer. This is the answer. 1 upon x 1 plus log x whole square. Yeah, this is the answer. Now next question, last question. Question number 4. Question number 4. Y is equal to 1 minus x square upon 1 plus x square. Y is equal to 1 minus x square upon 1 plus x square. This is our question. Alright. Log y is equal to log y is equal to log 1 minus x square upon 1 plus x square. This is the question. Alright. Now, two ways you can solve this question. One, directly you apply the formula d dx of log x, 1 upon x, and then because it is not x, so once again you differentiate this total you can take as x. Alright. And then y is equal to log x. So dy upon dx is d dx of log x, which is 1 upon x. And because it is not x, so once again you differentiate this. So that is of the form u upon v, then apply the formula of quotient. Denominator into d dx of numerator minus numerator into d dx of denominator upon denominator square. Or you apply logarithmic formula that you have learnt in your class 9, ISC class 9. Log m upon n formula. So you get y is equal to log 1 minus x square and minus log 1 plus x square. Is this fine? Log m upon n. This total we are taking as m. This total we are taking as m. This we take as m. This we are taking as n. So log m upon n. Log m upon n formula. If you remember. Log m upon n is equal to log m minus log n. Log m minus log n. So this formula we are using. Alright. We got this. Now we differentiate. So on differentiating again you write down. On differentiating both sides with respect to x we get. What did we get? What are we getting? We are not getting anything. We are writing only d dx of y is equal to d dx of there is a formula d dx of separately d dx of this and d dx of this, right? So d dx of log one minus x square minus d dx of log 1 plus x square. Alright, now d dx of log x, again we will treat this as x, right? So d dx of log x is 1 upon x. 1 upon x. And this is not x, so once again we differentiate this 1 minus x square. So when we differentiate 1 minus x square, the derivative of 1 is 0 and that of x square is 2x, and x raised to pi n minus 1, so 2x, right? So, and minus is before that, so minus 2x you will get. When you differentiate 1 minus x square, you will get, should I write down? Okay, so I am writing. Into d dx of 1 minus x square. Minus 1 upon x means 1 plus x square into d dx of 1 plus x square. Alright? Clear? Now, next step 1 upon 1 minus x square as it is. 1 upon 1 minus x square. And d dx of x, 1 is 0 because it is a constant. You have seen, I think second formula, you see that. d dx of c, here c is 1. So d dx of any constant is 0. So d dx of 1 is 0. And d dx of x square, you understand, d dx of x square, which is n x raised to the power n minus 1. That means 2x. N outside and x raised to the power n minus 1. So 2x you are getting. Got it? Clear? So here, now these things you can write down directly because we have just started. That's why I am telling you all these basic things. Otherwise, that much you can write down directly. 1 minus x square is minus 2. Even you need not write down 0. So x square is 2x. And minus 1 upon 1 plus x square. And here 1 is 0. ddx of 1 is 0. And that of x square is 2x. So 0 plus 2x. Okay. Now minus 2x. Minus 2x upon 1 minus x square. This is also minus 2x upon 1 plus x square. Either you leave here only or you can simplify. You can further simplify. You can further simplify. The LCM will be, in the book they have given this much answer, like this only, but you can further simplify this. LCM is 1 minus x square 1 plus x square. Alright, even minus 2x we can take common, so that would have been better. Let me write down once again, otherwise you may not understand. Let me take minus 2x common. So if minus 2x common, then we get here 1 upon 1 minus x square and plus 1 upon, what do you say? Minus 2x is common, so inside 1 upon 1 minus x square, and here 1 upon 1 plus x square. Is that fine? Clear? What do you say? Now, next step, minus 2x as it is. Yes, minus 2x as it is, and here LCM will be 1 minus x square and 1 plus x square. Now 1 plus x square here, 1 plus x square and plus 1 minus x square. Is it okay? Okay. Now this minus x square and plus x square, they cancel each other. So x square cancel each other. So 1 plus 1 is 2. 2 2s are 4. So you are getting minus 4x upon 1 minus x square and 1 plus x square. This is the answer. Got it? Understood? This was the last question. I hope things are very, very clear. Okay? Thank you so much. Thanks.